Would you accept millions of genetically modified mosquitoes being released right in your neighborhood? In the Florida Keys, USA, this question is no longer hypothetical. A massive experiment involving over 1 billion mosquitoes carrying synthetic genes is turning local residents into witnesses, or perhaps even lab rats, in an unprecedented genetic revolution. These mosquitoes are engineered with a self-destruct gene that causes their offspring to die before reaching adulthood. In theory, this could be the key to wiping out dangerous diseases like dengue fever at their root. But are we truly solving a public health issue, or are we opening a Pandora's box of ecological consequences no one knows how to close? Today, let's join Terran Works in decoding the story behind this bold decision. Aedes aegypti is not native to North America, but it has become one of the most successful invasive species in modern history. It arrived in the Americas aboard slave trade ships from Africa in the 17th century and gradually adapted perfectly to urban environments. Today, in southern states like Florida, Texas, and California, Aedes aegypti has deeply rooted itself into human life, turning residential areas into its ideal habitat. Why is it so dangerous? Unlike typical mosquitoes, Aedes aegypti is a true human parasite. It prefers to live indoors, hiding under tables, in closets, and specifically feeds only on human blood. Just a small puddle left after a rainstorm can become a nursery for hundreds of mosquito eggs. Aedes aegypti doesn't just spread disease, it causes constant anxiety, disrupts outdoor activities, and places a massive burden on healthcare systems. As global temperatures rise, the range of Aedes aegypti is gradually expanding northward, threatening states that have never before experienced outbreaks of dengue fever. In the past, the only and most effective solution was spraying insecticides. Specialized trucks would drive through the streets, releasing thick white clouds of chemicals like permethrin or malathion. However, nature always finds a way to survive. After generations of exposure to these chemicals, Aedes aegypti has developed an astonishing resistance. A study in Florida found that up to 90% of the local mosquito population carries genetic mutations that allow them to survive even high concentrations of insecticide. Continuing to use chemicals not only becomes ineffective but also leads to serious ecological consequences. Insecticides are non-selective. They kill beneficial insects like bees and butterflies and pollute water sources, ultimately harming human health. The more we spray, the stronger the mosquitoes become, while the environment grows weaker. Scientists realize that to defeat a biological organism, we need a biological solution. And that's when a highly controversial decision was made. The decision to intervene in mosquito genetics didn't come from impulse, but from desperation. When all conventional tools had failed, scientists asked a new question. If we can't kill mosquitoes faster, can we make them disappear on their own? Instead of attacking mosquitoes from the outside, the new solution targets their reproduction, the key factor in any population's survival. If female mosquitoes cannot reproduce successfully, the spread of disease can be stopped at its root. This isn't a new idea. The sterile insect technique has been used on flies and crop pests since the mid-20th century. But with mosquitoes, the scale and risks are far greater. Genetic intervention is seen as a last resort option, precise, targeted, and free from chemicals. But it also places humans in a completely new role. Engineers of evolution. And for a genetic idea to affect an entire population in the wild, science alone isn't enough. It has to be scaled to an industrial level. Imagine a factory where the product isn't electronic components, but millions of living organisms. Welcome to the world of Oxitec, a leading biotech company in pest control. In their advanced breeding facilities, the mosquito production process is carried out with absolute precision. Mosquitoes are raised in massive water trays, where temperature and humidity are tightly controlled. The key to this industrial-scale process is sex sorting. In the mosquito world, Only females bite and transmit disease, while males feed on nectar and are completely harmless. Oxytec's technology enables them to mass-produce male mosquitoes carrying a special gene. The process requires microscopic precision. Technicians inject the gene into mosquito eggs under a microscope, working at the micrometer level. These billions of eggs are then packed into smart mosquito release boxes. Just add water, and these boxes become natural incubators right in the field. The Genetically Modified Mosquito (GMM) project is based on a simple but ruthless scientific principle: the gene that limits life. Oxytec's male mosquitoes carry a lethal gene that prevents female offspring from surviving past the larval stage. Once released into the wild, these males seek out and mate with wild female mosquitoes. What's the outcome of this union? All female offspring die before they can mature and fly. Only the male offspring survive, continuing to carry and pass on the gene to future generations. Over time, the number of female mosquitoes, the source of both disease and reproduction, gradually declines until the entire population collapses. In the Florida Keys, millions of genetically modified mosquito eggs are placed in small boxes hung on trees, fences, or in residents' backyards. But in larger areas, manual methods aren't enough. Drones and light aircraft are used to release mosquitoes over vast regions with high precision, ensuring even distribution without needing to physically access each neighborhood. These quiet flights make it possible to deploy hundreds of thousands of mosquitoes in a short time, scaling up control efforts to an unprecedented level. The initial results from trial projects in Brazil, the Cayman Islands, and most recently Florida have astonished the scientific community. In some regions of Brazil, after releasing Oxytec mosquitoes, wild Aedes aegypti populations dropped by up to 95%, a number no chemical pesticide has ever achieved. In Florida, preliminary results also show excellent compatibility. Scientists observed that the genetically modified male mosquitoes were highly competitive in mating, performing just as well as their wild counterparts in attracting female mates. More importantly, there is no evidence that the modified genes are spreading to other mosquito species or causing harm to humans. However, statistical success doesn't mean everything is smooth sailing. While mosquito numbers drop, maintaining that result requires continuous releases. If the releases stop, wild mosquito populations from surrounding areas can quickly move in and fill the gap. This is an effective solution, but one that demands long-term commitment and stable funding. A major question arises. If we eliminate mosquitoes, what will happen to their predators, like dragonflies or birds? This is a central point in ongoing ecological debates. Opponents worry that removing a link in the food chain could cause a domino effect. Dragonflies, bats, and certain bird species rely on mosquitoes as a key food source. If mosquitoes disappear, will these predators starve? However, biologists offer a different perspective. First, Aedes aegypti is an invasive species. It is not a native part of the American ecosystem. Eliminating it would, in fact, help restore the natural balance. Second, there are thousands of mosquito species in nature, and most of them don't transmit diseases to humans. Oxytec's project targets only Aedes aegypti. Predators will still have plenty of other insects to feed on. Furthermore, reducing the use of chemical pesticides is actually good news for dragonflies. Pesticides kill dragonflies far more directly and harshly than the absence of a single mosquito species ever could. By replacing chemicals with genetic technology, we are, perhaps unintentionally, protecting these natural bodyguards and allowing them to thrive in a cleaner environment. However, nothing is absolute. When we play with the genetic code of nature, hidden risks always loom like a shadow. Public opposition is not without reason. Environmental activists warn of a potential Jurassic Park scenario. What if this life-limiting gene mutates and malfunctions? Could it result in a new breed of super mosquitoes, even more dangerous and resistant to all control methods? There are also concerns that genetically modified mosquitoes might unintentionally transfer foreign genes into wild populations during mating, altering their biology in unpredictable ways. In Brazil, one study found that fragments of genes from modified mosquitoes had persisted in local populations over several generations. While there is no evidence that this caused harm, it highlights just how thin the line is between the laboratory and the natural world. There's also the issue of community consent. Many Florida residents feel they are being treated like lab rats in a massive experiment they never agreed to. A lack of transparency in some corporate reports has fueled even more skepticism. Are the profits of biotech companies being placed above long-term ecological safety? These are ethical and scientific questions humanity must answer before releasing billions of these biological machines into our shared environment. Each year, dengue fever remains one of the most serious mosquito-borne diseases worldwide. According to the World Health Organization, between 100 to 400 million infections occur annually, leading to over 500,000 hospitalizations and claiming 20,000 to 40,000 lives, the majority of them children. Over the past 50 years, the spread of dengue has increased more than 30-fold, making it one of the fastest-growing infectious diseases in the world. In the US, dengue is not yet widespread, but it is emerging as a new public health threat. The CDC has reported a clear rise in cases over the past decade, with local transmissions recorded in Florida, Texas, and California, areas where Aedes aegypti mosquitoes are now firmly established. The Florida Keys alone have experienced multiple consecutive outbreaks, forcing local authorities to spend over $1 million per year just to control disease-carrying mosquitoes. Unlike common fevers, dengue causes severe joint and bone pain, prolonged fatigue, and can lead to internal bleeding, shock, and death if not treated promptly. For public health systems, genetically modified mosquitoes are more than just an insect control method. They represent a biological shield. When female mosquito populations are reduced, the virus transmission chain is cut off at its source. Epidemiological models show that just a 50 to 70% reduction in Aedes aegypti density can drastically lower the risk of outbreaks, and that's why a root-level intervention has become necessary. The story of genetically modified mosquitoes doesn't end in the United States. As dengue and other mosquito-borne diseases continue to spread, more countries are being forced to confront the same survival dilemma. From the crowded slums of Brazil to rural communities in Africa, mosquito intervention technology is becoming a global front line in public health. Brazil is currently leading the way, with industrial-scale mosquito production facilities set up to protect millions from dengue fever. In Southeast Asia, countries like Indonesia and Vietnam are taking a different approach, using Wolbachia bacteria to disrupt the mosquito's ability to transmit viruses, rather than wiping out populations with self-destruct genes. In Africa, where malaria still claims hundreds of thousands of children's lives every year, scientists are going even further with gene drive technology, a method capable of spreading modified genes throughout an entire natural population within just a few generations. It's the most powerful tool ever proposed, but also the most controversial. In this context, the world is watching every step taken by the US and Brazil. Each country has its own ecosystems and legal boundaries, but the shared goal remains: to defeat deadly diseases without destroying the natural balance. The war against mosquitoes has become a global experiment, one in which humanity is, for the first time, confronting evolution with its own technology. Genetically modified mosquitoes aren't just a story about insects. They're a story about how humanity confronts its own limits. When chemicals fail and nature resists control, we turn to technology as a way out. In the short term, genetically modified mosquitoes may reduce disease and save lives. But in the long term, the cost remains an open question. Ecosystems don't operate on simple models, and every intervention leaves consequences behind. What do you think about this issue? Leave a comment below, and don't forget to subscribe to the channel so you won't miss any of Terran Works' upcoming journeys.